Matematik icat mıdır, keşif midir? Tanrı soyut varlıklar yaratmış mıdır?
Thank you to the organizers for inviting me to discuss these two questions that have a vast literature. And it seems to me that if you answer yes to the first question, that God did create mathematical objects, then you would almost surely say that mathematics is discovered. Because if God created something, then it is out there for humans to be able to discover. They have the capacity to do so. But if you answer no, then you can find both theists and atheists who would give possibly either answer to the question of whether mathematics is discovered. Let's take a sample of those thinkers. First, some theists who would say that God did not create mathematical objects and mathematics is invented. The first, the well-known philosopher George Berkeley, Bishop of Cloyne, who says this: "The idea of man that I frame to myself must be either of a white or black or tawny or straight or crooked or tall or low or middle-sized man. I cannot by any effort of thought conceive the abstract idea above described." In other words, for Berkeley, there are only concrete things, not universal abstract things. Berkeley was a nominalist, and so anything that humans do by way of mathematics is something that they invent, because there are no abstract objects to discover. The nominalist and contemporary philosopher William Lane Craig finds a theological problem with Platonism, that is, the view that there are these independent objects that are out there for people to discover. He says this: "The chief theological failing of Platonism, and therefore the reason for its unacceptability for orthodox theists, is that Platonism is incompatible with the doctrine of creatio ex nihilo, and so fundamentally compromises divine aseity." I'll be talking a little bit about those terms a little later, but let's go to the idea that mathematics is discovered. And surprisingly, here are two atheists who would say that mathematics is discovered. The first is the famous British mathematician Gottfried Harold Hardy, who says this: "I believe that mathematical reality lies outside us, that our function is to discover or observe it, and that the theorems which we prove and which we describe grandiloquently as our creations are simply the notes of our observations." So the atheist, G.H. Hardy, thought that mathematics had an independent existence that we discover. The atheist, Sir Roger Penrose, in Shadows of the Mind, says this: "The natural numbers were there before there were human beings, or indeed any other creature here on earth, and they will remain after all life has perished." Now, for an example of a person who thought that mathematics is created by God, and therefore that humans discover mathematics, is Augustine of Hippo. He had a theistic casting of Plato's doctrine of forms, which are these independent entities, and he located mathematical objects as part of God's nature. That's most clearly expressed in his book on the free choice of the will. Let's talk about Plato and Aristotle, because from those two philosophers we get these two diverging views of mathematics being created or discovered. Plato and Aristotle, according to the philosopher Arthur Holmes, gave birth to the schools of rationalism from Plato, with various proponents, Descartes, Spinoza, Leibniz, and so on, and Aristotle, giving birth to empiricism. Plato, knowledge comes from reason; Aristotle, knowledge comes from experience. This is, of course, painting with broad strokes, but proponents of empiricism, the British philosophy trio, Locke, Berkeley, and Hume. And then we have, according to Arthur Holmes, an important philosopher who published in 1791 Critique of Pure Reason. From him, the tradition of rationalism tended to go into German idealism, with proponents of Frege, Hegel, and Schopenhauer. And in the Aristotelian tradition, positivism, with proponents Karp, Mill, and Quine. Now, what did Kant do in 1791? Well, we can think of rationalism and empiricism as being forms of a priori knowledge, something that comes independent of experience, and a posteriori knowledge, where we get our knowledge through experience. An example of an analytic truth that is a priori would be something like this: a bachelor is an unmarried male. The subject contains the predicate. The subject being a bachelor, part of what it means to be a bachelor is that you're an unmarried male. For an a posteriori analytic truth, where the subject contains the predicate, it would be, according to Kripke in his book Naming a Necessity, the evening star is the morning star, speaking of the planet Venus. Now, you only know that from experience, but once you know it, it's an analytic truth. The subject contains the predicate. An example of a synthetic truth where the subject does not contain the predicate would be something like Ankara is the capital of Turkey. We only know that Ankara is the capital of Turkey by virtue of experience, but there's nothing in the subject, Ankara, that would logically determine it to be the capital of Turkey. Kant proposed the idea that there is such a thing as a synthetic a priori, a truth where the subject does not contain the predicate, yet they are known independent of experience. And for Kant, it would be a mathematical proposition like 7 plus 5 is 12. That is something we know independent of experience, according to Kant, and yet there's nothing in the subject, 7 and 5, by themselves, that contain the predicate, that they happen to equal 12. According to the philosopher of mathematics, Alexander Passot, prior to the 1800s, it was plausible to maintain that mathematics was about abstractions of qualities observed in the physical world. In other words, that was the purpose of mathematics. That was its subject matter. The advent of non-Euclidean geometry rendered that view untenable. Non-Euclidean geometry is a little complicated, but let's illustrate it by looking at these two axiom sets, which are just kind of made up, but they sort of parallel on the left Euclidean geometry, and on the right non-Euclidean geometry. They're not the axioms for those two systems, but they illustrate the interesting conflict. You'll notice that the first four axioms are the same. A line in this system is simply a column of numbers, and a point is a number. So in axiom set 1 looks like there are 12 lines, and in axiom set 2 there are 7 different lines, 7 different columns. 9 points in the first axiom set, 7 points in the second axiom set. Now the interesting bit is the first 4 axioms are the same, and the fifth axiom say radically different things. The fifth is like Euclidean geometry. Through a point not on a given line, there's exactly one line through that point that has no points in common with the given line. The second is more like hyperbolic geometry. Any two lines have at least one point in common, or maybe Riemannian geometry would be a better representation. The important thing to note is that you cannot prove the fifth axiom from the first 4 axioms, because if you could, you would be able to prove two opposite things. And this system appears to be consistent because you have two models that faithfully represent the axioms in both of those systems. So how does this relate to mathematics being created or discovered by God? Well, you might say, according to Augustine, that yes, there are different axiom schemes that say different things, and they both can't describe the real world, but nevertheless, they still can be residing in God's thoughts. So, for Platonism, we have a realist ontology of mathematics, the truth value of mathematics, whether it corresponds to reality or not, is that it is independent of human proof. For an anti-realist position, such as a nominalist, the truth value of mathematics depends on its demonstrability, not on its correspondence to an external independent reality. So let's go back to this objection by William Lane Craig about creation ex nihilo being incompatible with Platonism, and actually talk about that and another problem that would arise from the view, if you are a theist who believes that mathematical objects are independent, that they are eternal and necessary, but yet they are created by God. How does that work? Well, there is that aseity problem that William Lane Craig mentioned. For theists, God is the only being that exists a se. That means in and of himself. So there's an aseity problem. How can mathematical objects be independent? Well, for Augustine, they're not independently created. You would have to change your view of creation a little bit to say that God creates mathematics as meaning this. He creates mathematics in virtue of his continually sustaining them, so that they are eternal and created, not in the sense that they're created by virtue of their having gotten some ontological momentum at some point, but only because they have always existed in God's thoughts, and so God creates them in the sense that he continually sustains them. But now there's another problem that a theist would have. If you think that mathematical truths are eternal and necessary, and that's the freedom problem. It seems like 5 plus 7 equal 12, thoughts like that, propositions like that, it seems like they are always true, eternally true, and that they're necessary. So, could God create a world in which 1 plus 1 does not equal 2? Or 5 plus 7 does not equal 12? If you say that God couldn't do that, that seems to constrain God's freedom. But in further reflection, a possible solution would be this is not a constraint if mathematical propositions are simply expressions of God's fundamental nature or his fundamental thought processes. According to the scriptures in Hebrews chapter 6, verse 18, for instance, it is impossible for God to lie. God cannot lie because it is part of his nature to tell the truth. And so if it is part of his nature to conceive of mathematical propositions like 5 plus 7 equals 12, then it is no constraint on his freedom. Now, Chris Menzel has discussed those two problems in a paper, Theism, Platonism, and the Metaphysics of Mathematics, that was rewritten for Chapter 3 of the book, Mathematics in a Postmodern Age, A Christian Perspective, that Jim Bradley of Calvin University and I are co-editors and contributors to. And here is a problem. This is quite technical, so I'll go through it rather quickly and trust that it will be up on the screen for those that want to pursue it a little more closely. But there's a problem with thinking about the set of all propositions. If God created mathematics, then he created all propositions. And so there would be a set, a collection of all propositions. Well, that gets into a nasty logical problem, and it works like this. Let's let S be the set of all propositions, and let P be any property. Let's adopt the principle that if two sets X and Y are different, then P of X is not the same as P of Y, where P of X denotes the proposition that set X has property P. In other words, if X is not the same as set Y, then it's not the same proposition to say X has property P as it is to say that Y has property P. That seems reasonable enough. But now let set be the property of being a set. So capital SAT is that property. And consider the set of these propositions. Every set that is the power set of S. So the power set of S is the set of all subsets of S. S is the set of all propositions. And you would have this proposition, that S is a set, where S is the set of all propositions. Now again, this is technical, but by that principle we discussed earlier, the power set of S is in a one-to-one correspondence with the set T, but T is a subset of S because T is a set of propositions. And according to Cantor, you cannot have a one-to-one correspondence between a set and its power set. Again, that's technical. So I'll just leave that screen present for a minute for those that want to take a quick look at it sometime later, or a more detailed look. But this can get resolved. The problem generally is, without worrying about the details of the argument, there is no such thing as the set of all propositions. And so how could God know all propositions? Well, this was debated by the philosopher Alvin Plantinga and William Grimm in 1993. And Plantinga says this, which I think is very interesting. I agree there is no set of all propositions. Let's acknowledge that, according to this technical argument. That does not mean that God does not know all propositions. I think that has some intriguing possibilities. Let me close with some mysteries of mathematics that would run up against some real conundrums depending on what view you might take of God and creation and mathematical objects. The natural numbers pictured on the left, the counting numbers, 1, 2, 3, 4, 5, and so on, can be lined up with a one-to-one correspondence with the even numbers, 2, 4, 6, 8, 10, and so on. There's a complete matching, so that those two sets, though infinite, correspond with each other exactly according to the scheme that you see. Yet Georg Cantor, the person I talked about just a minute ago, was able to show that the real numbers, there is no one-to-one correspondence with them and the natural numbers. Now, by real numbers, we mean just not only the counting numbers, 1, 2, 3, 4, 5, but also fractions like 1/2 and 1/3, transcendental numbers like pi, irrational numbers like the square root of 2. Cantor proved that those two sets have no one-to-one correspondence. In other words, there are different sizes of infinity. The real numbers have actually a larger size of infinity than the natural numbers. That's quite a mystery. And if you ask a mathematician, how can that be so? The answer you'll get is something like, that's just the way it is with infinite things. Now, Cantor proposed a continuum hypothesis, saying that there is no collection of objects whose size is between that of the real numbers and the rational numbers. So the natural numbers or rational numbers have one size of infinity. The real numbers have a larger size. Cantor says there's nothing in between them. So let's test your intuition. What do you say about the continuum hypothesis? Now that you know that there are different sizes of infinity, is there a collection of objects between those two, between the size of the natural numbers and the size of the real numbers, or not? In other words, is the continuum hypothesis true or false? Well, this question actually has 3 answers. The first is yes, the continuum hypothesis is true or false, and it's true. Or you might say yes, the continuum hypothesis is true or false, and it's false. You would answer that way if you're a mathematical realist, especially if you think that God created mathematical objects. If you are a nominalist, you might say no. The continuum hypothesis is neither true nor false, because it has been proved that with the currently accepted axioms of set theory, you cannot prove the continuum hypothesis to be true or false. So where does that leave us? The Bishop of Hippo would say that it's possible for God to know something that's unprovable. And we might have a convergence of agreement here on this one issue. It is the mysteries of mathematics that lead us to ponder not only our own limitations, but also the greatness of the mind of God.